Hi everyone. Today we are going to start a new chapter. Uh, start. Hi everyone. Today we are going to start a new chapter. And we are going to start with the quadratic expressions at the end, its definition. So first of all, we should know that the quadratic any expression in the form of ax squared plus bx plus c, where a, b, and c are constants, and with the only restriction, which is a shouldn't be equal to 0. Okay, why? Because we want to call it quadratic expression, where the term ax squared is clearly present in this expression. And if a equal to 0, so normally this term will be deleted. So no more quadratic expression. So the general form of a quadratic expression is ax squared plus b of x plus c, where a, b, c are real constants, and x is the only variable involved in this expression. Where to use it? Where we can, for example, operate with such expressions in any real life problem issue. So normally we have a rectangle with dimensions as it follows. Length 6 centimeter more than its breadth, and we want to complete to write an expression for the area. So first of all, we fix one of these dimension as the variable, and we write the other in terms of the unknown. Okay, so if we let the breadth equal to x, and we know that the length is 6 more than the x, so like the length equal to x plus 6, and we already know that the area of any rectangle equal to the product of the breadth by length equal to x plus 6 by x, or the inverse, or we say the opposite, x by x plus 6, because we know that 2 by 3 equal to 3 by 2, so normally the product is commutative. Okay, so normally we expand to obtain this term will multiply all the terms inside the parentheses. So normally, first of all, how to proceed with this expansion? First of all, we multiply the signs, we multiply the numerical part, and then finally we multiply the unknowns. We have a plus and a plus. We have a nothing, so positive same sign equal to positive. We have a numerical part here, 1 and 1. Y by 1 equal to 1. X by x, we have the same base, and we know x by x, we add the components because we have a product between them. So normally we add the exponent, we obtain, we have a nothing, we have a 1 plus 1, so we will obtain x squared. Then a plus and a plus, it is like a plus. 1 by 6, it is a 6, and x with nothing equal to x. So centimeter squared. Why? Because we have a length in the centimeter, and we have the breadth in centimeter. So we know that the area unit equal to centimeter squared, the unit of length. Okay, used squared. Good. And you can assess yourself by the remaining exercises in the using and adopting the same way, the same method that we did in the first example. We have a triangle, has a perpendicular height 3 centimeter more than its base length. So let assume that the base length equal to x. Okay. So if we assume that the base length equal to x centimeter, then the height is 3 more x in the same unit length centimeter. And we know that already know that the area of any triangle equal to the half of the product height by base. So normally, if we expand, as I said before, plus to plus, it is like plus, 1, it is a 1, x squared, positive, 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 and 1 by 3 is 3x, because we know that when we expand a term by parentheses, so we multiply this term by all the terms inside this parentheses, and we know that if we have a common denominator, so it is like the same denominator, we keep the same denominator for each term, so we write it as x squared over 2 plus 3 over 2x. Good. So good and easy for the rest of the exercises. Sometimes we can expand and simplify the expressions using a diagram. Which diagram? For example, we have a rectangle with sides x plus 4, x plus 6. So we can split it, divide it into 4 small rectangles and not squares like we see here. It is like rectangles. Okay, the only square that we have in the first one, this one is a square. Why? Because all sides are of the same length, Okay, so we split it into 4 rectangles. Okay, the first rectangle, the first, for example, the length or the breadth, we split it into x plus 4, and the length of the biggest, the original rectangle, we split it into x, 2 segments, x plus 6. And we count the area because we know the area is the surface of the whole rectangle. We can, for example, we can obtain it by adding the surface of each of these small rectangles inside. Okay, so first of all, x by x squared, 4 by x, it's like 4x, and the surface of this one is 6 by x is 6x, and this one we have a 6 because this side and this segment are of the same length, and this segment of the same length, so 6 by 4 equal to 24, and we add all these, we join and we add the like terms. Like here, what are the like terms? 6x, 6x. The like terms are the terms with the same polynomial. We have a x, we have a x. So normally are the same. We can combine it. 6 plus 6 is 10. 10 of what? 10x. And so, as I said before, using a diagram to ease your work is very, very advisable here. And like how to expand, normally how to expand a given, for example, given expression with some groupings. So we have factor x plus 3 by x minus 5. In the first parenthesis, we have 2 terms, and the second we have 2 terms. So easy to expand and to simplify the following. How? We say that x should multiply all the terms inside the second parentheses, and then 3 should multiply all the terms inside the second one. How? We can describe the process. It is like x by x minus 5 plus 3 by the factor x minus 5. Okay? Then easy. Each term multiply both inside. 3 multiply both inside. And as I said before, to simplify your work, it is easy to proceed this multiplication to multiply first the signs. If you have the same signs with this product, you obtain a positive and opposite side negative. You multiply the numerical part, then the pronumeral or the unknowns. So it is easy to split the first bracket, then multiply each term by the second bracket and simplify your work. So it is very easy to find your way in solving these or obtaining these quadratic expressions. And same for this one. But here they ask you to substitute x by 4 and minus 3 instead of y to obtain the value of this expression. So it is easy to replace x by 4 and 3 by -3. So normally 4, 16. You proceed and you substitute the value, then evaluate the equation. It is easier to do that. Okay, be careful with the signs. And finally, the same process that we explained before, but we have a 4 as extra term. For example, if we have a minus before the two parentheses, it is not a big deal. But if you have a minus like here, you should be careful and very aware about using this minus and how to multiply it with the remaining parts or the right hand side of this operation. First of all, we put like isolation. I used here the braces or brackets, okay, or braces, anything. Brackets is very good to use, and we proceed inside to multiply and simplify these ones. So we have a x by x plus 2, we have a -3 by x plus 2. Good. How many terms inside we have? If you to start counting the terms, first of all, we have a x by group of terms. So normally when we have a product, so we are still in the same term. So normally the first term or the first expression finished here. Secondly, we have a minus and we have a 3 by a group of terms. So the second expression is here. So if we want to enter this minus to the following expressions, so instead of having x, we all have the opposite of x, minus x, and the whole remaining part of this one. And if we have a minus, we will obtain the opposite. Minus is a +3 and with the remaining parts. And then we proceed as we know. So we have a minus x minus x squared minus a plus a minus 2x plus positive 3x, and the plus is a plus 6. And finally, we simplify by adding the like terms. We have a -2x plus 3x is a 1x, because we know that minus plus 3 equal to 1 of x, because we have a x, or the family here is x. These are the important ideas of this lecture. Thank you for listening. Have a nice day.